Are you struggling to compute confidence intervals for your predictions using the XGBoost package in R? You're not alone. This is a common challenge many face when working with regression models. I totally get it. It can be really frustrating when you've built a model and then hit a wall trying to interpret your results. You're not the only one who has felt this way. Many data scientists encounter similar hurdles. Let's dive into the specific question at hand. One user recently asked, "How can I compute the confidence interval for my predictions using XGBoost in R?" They mentioned having a dataset with 4 categorical input variables and 1 numeric output. Sound familiar? Let's explore this together. So, what exactly is the issue here? When using XGBoost, calculating confidence intervals isn't straightforward because the package doesn't provide this functionality out of the box. But don't worry, we can work around this. And stick around. By the end of this video, you'll not only know how to compute confidence intervals, but also gain insights that can enhance your model's performance. To compute the confidence interval for predictions made by the XGBoost model, the user should first ensure that they have the necessary libraries loaded in R. This includes the XGBoost package and the dplyr package for data manipulation. Next, the user should make predictions using their XGBoost model. After obtaining the predictions, they will need to calculate the standard error of these predictions. This can be done using the predict function along with the model's parameters. After obtaining the predictions, the user should calculate the standard error. This involves using the residuals from the model to estimate the variance. The user can then compute the confidence interval using the mean prediction, the standard error, and the desired confidence level. Finally, the user can visualize the confidence intervals alongside their predictions. This can be done using a plotting library like ggplot2 to create a clear representation of the results. Fun fact, did you know that the concept of confidence intervals dates back to the 1930s? It's amazing how statistical methods have evolved over the decades. Now, let's look at the answers provided by other users. This user suggests that there isn't a direct method to compute confidence intervals using the XGBoost package. Instead, they recommend a technique called bagging. This involves creating multiple models with some randomness. By adjusting parameters like cull sample by tree and subsample to less than 1, you can introduce this randomness. Running the model multiple times with different seed values will give you various predictions for each observation. You can then calculate a custom confidence interval using the mean and standard deviation of these predictions. Here's a sample code snippet to illustrate this process. First, create an empty data frame for predictions. Then, generate 100 unique seed values. In a loop, set the seed, train the XGBoost model, and store predictions for each run. This will help you gather the necessary data to compute your confidence intervals. Let's take a look at an answer from another user. An alternative approach to compute confidence intervals for XGBoost regression is highlighted in a blog post. This method is considered more elegant than others. It involves obtaining quantiles from your regression model. The blog explains that if the quantile value is far from observed values, the model may not split effectively. To address this, randomization can be added to the gradient, which helps force a split when differences are large. Here's a pro tip. Always visualize your confidence intervals alongside your predictions. This can provide valuable insights into the reliability of your model's outputs. And there you have it. You now know how to compute confidence intervals for your XGBoost predictions in R. Remember, practice makes perfect. If you found this video helpful, please subscribe for more tips and tricks.